Hi, I'm Tabitha Graves. I'm a PhD student here at the School of Forestry. I work on grizzly bears and particularly the spatial ecology of grizzly bears. I'm linking habitat relationships up with grizzly bear demographics, so abundance, gene flow, and dispersal. I first came to NAU after working for a long time with my collaborators in the USGS on grizzly bears. And I'd been talking with them about these kinds of questions and doing these kinds of analysis, and I was also interested in getting a PhD. So I started looking around for options where I could get my PhD doing the project that I'm working on. And as I started searching around and looking for funding for that, I found NAU had an NSF IGERT program at the time that fit my project well, which was themed to, the theme was genes, going from genes to the environment. And when I started looking into that and started looking at the professors that were here at NAU, Paul Beyer immediately jumped out as somebody that I would really like to work with. Paul's papers were some of the first papers I ever read that had to do with corridors and connectivity theory relating to wildlife, and so I was really excited to get the chance to meet him and talk to him. I asked around, and everybody had very positive, all of his previous grad students had very positive things to say about Paul, very positive things to say about the whole program, and about people being nice and it being a supportive environment and a good place to learn. So I ended up contacting Paul and doing an interview and applying for that NSF IGERT fellowship, and I got that fellowship. And then Paul and I worked together on an NSF grant to get more funding for an additional 2 years. And so I was then funded for the rest of my time here, and that's in addition to just being a really great project for me. Of course, it's a great resume builder to have those kinds of fellowships and grants on my resume. So those things have been a really fantastic aspect of my time at NAU. And the good news is that the purpose of the grant was to develop a method where you could quantify resistance values. In other words, talking about how difficult it is for animals to move across the landscape. And we did it. Paul's really interested in connectivity and trying to create conservation corridors. Paul was most interested in that, and I was also interested in the gene flow piece of it, and in connectivity and corridors, and I've worked on those kinds of issues with bears before. The other parts of my project that are really cool, so identifying why there's more bears in some places than others, is looking at trying to identify the habitat factors that influence abundance instead of just looking at the habitat factors that influence habitat selection. So we're going up a scale in terms of the response variable that we're looking at. The third part of my project that I haven't talked about yet is looking at dispersal and trying to look at how habitat influences dispersal. And for that, we're basically creating a family tree with all of our individuals. We have over 545 individually genotyped bears, and the grant funded some additional loci, some genetic loci, to extend that so we have a total of 24 loci. And from that family tree, then we can look at mother-kid offsprings and try to see where they've moved and how they've moved across the landscape. In 2004, we put out 2 different kinds of sampling methods. We put out something called hair traps and something called bear rubs or rub trees for the bears. And basically, a hair trap is a corral with barbed wire around several trees with a very stinky pile of wood in the center that's covered with this scent lure. And the bears love it, and they come in and they roll around in it and sniff it and enjoy it. And as they're going across that barbed wire, they leave hair behind. And we use that hair to collect genotypes, and using that data, we then know which bears were where and when they were there. And so that's the basis of the data that I'm using to try to look at why there's more bears in some areas than in others, and gene flow and dispersal. The rub tree method is basically trees that bears rub on naturally, and what we do to find these trees is just go around and look for places where bears have rubbed. They'll still have bear hairs on them stuck in the sap of the tree, and then we just add barbed wire, little strands of barbed wire to that, and then when the bears just rub on them, then they also leave hair behind that way, and we can genotype that as well. My main collaborator in northwestern Montana is Kate Kendall, and she's a USGS research scientist. And I actually worked for her for several years as a spatial analyst, so I did their mapping and was working on some of these analyses even before I decided to go back to get my PhD. She's one of the major bear researchers in that area, and I did my master's in Montana, so I'd met her through that, and she was impressed with my master's work and asked me to work for her. So yeah, and she's been really marvelous as a collaborator and continues to be involved on everything that I'm doing in terms of this data. She's got several projects actually, and so originally I worked with her on some data from 2000, which encompassed a much smaller study area. The 2004 data, which I'm working with for my PhD, covers pretty much the whole ecosystem that's within the U.S. border, the south of the U.S. border. So it's an 8 million acre study area, and goes from the Canadian border all the way down to the Missoula area. So it's a very large, comprehensive project. It's definitely the kind of project that you couldn't do by yourself, even as a PhD student, that you need lots and lots of collaborators.